Good day everyone. We will discuss about the performance impact due to type conversion or implicit conversion in this video. Let's get started. I'm going to use database JBSWiki for this demo. I'm going to create two tables, table 1 and table 2. Table 1 gets its data from a backup table called table1 underscore backup, and table 2 gets its data from a backup table called table2 underscore backup. Table 1 has a primary key constraint on column 1, and it also has a non-cluster index on table 1 on column 8, which includes column 2 also. I'll be updating the top 10 rows on table 1 for column 8 to value test. We have primary key constraint on table 2 on column 1. So I'm going to execute this particular select query with an actual execution plan. So what I'm basically doing is like I'm selecting table 1.column1 and table 2.column2 from table 1, which basically joins with table 2, and we have this join condition and then the predicate here. So this value is a local variable which is a data type of nvarchar10. So let's execute that. Let's look at the execution plan. So what I'm seeing here is like there are two things that I'm seeing as little odd. So the first one is like we are doing a major scan, index scan on table 1, and another one is like we have a warning here. So first let's look at the index scan. So what I'm basically doing is like I'm estimating close to 16 lakh rows. The estimated number of rows is like close to 16 lakhs, and the number of rows read is also close to the same value, 16 lakhs, and then the actual number of rows is 10 here. So that means we are estimating 16 lakh rows, and then we are returning only 10 rows as the output for this select query. But in order to return that 10 rows, what we are basically doing is like we are scanning through the whole table, reading each and every record, and then basically coming to a conclusion like we need to return 10 rows, and that is getting returned. So what I'm understanding is like we are reading a lot of rows on this particular SQL query and then returning only few rows. Now, if I go back to the warning there, the warning basically tells us like there is an implicit conversion. There is a type conversion in expression, convert underscore implicit nvarchar on column 8, and this may affect seek plan in query plan choice, and this clearly tells like why we are getting an index scan instead of an index seek, even though we have a proper non-cluster index created. So if we look at the query again, what we are seeing is like we are seeing an implicit conversion on this particular thing. So what we'll do is like we will disable the execution plan, and then let's look at the properties of table 1 and then see what is column 8. So column 8 as a data type of varchar. So what we are doing here is like we are comparing varchar column 8 with an nvarchar value. So that is the reason we are going for an implicit conversion, and that is causing a huge performance impact because we are scanning through the whole table, and that's the problem right now. So moving on, let's look at the second query. So this query seems to be straightforward. The only difference is like we are not using a local variable. Instead, we are moving the value directly for the predicate. Yeah. So let's execute this query. We need the execution plan. So let's enable the execution plan and then execute it. And what we are seeing is like we kind of seeing the same behavior. As far as table 1 is concerned, we are estimating 5 rows. But we are reading close to 16 lakh rows, which is 15 lakh 99,877, and then we end up returning only 10 rows. So what is happening? We are estimating 5 rows. We are returning only 10 rows. But in order to return that 10 rows, we are reading through each and every record on that particular table, which is table 1. So we are reading each and every record and then coming to a conclusion like we need to return only 10 records. We are not pinpointing the rows, and we are not reading just the 10 rows. We are basically reading the whole table and then returning the returning that 10 rows. And now if I look at the warning is same. It basically tells like type conversion in expression, convert implicit nvarchar. So what is happening is like optimizer is treating it as an nvarchar, since we have mentioned an Unicode here. So now let's look at the solution. For the first query, what we'll do is like we will change this nvarchar to a varchar, and then let's execute that query. Now if you look at the execution plan, we have an warning, but what we are not seeing is like there is no more an index scan on table one. We are seeing an index seek right now. Yep. And then now if I look at the statistics, what I'm seeing is like we are estimating 16 lakh records, but what is happening is like since it is an index seek, what we are seeing is like we are returning just 10 rows, which we already know. But in this case, now we are doing an index seek. What we are doing is like we are not reading the whole table. Instead, we are just reading 10 rows and then returning those 10 rows. So optimizer is able to pinpoint the rows that is required for this query with the usage of this non-cluster index seek, and then it is able to return those rows without performing excessive reads. Now let's look at the warning here. So this warning is related to the memory grant. This is something not related to at least this demo. So we are no longer seeing any kind of implicit conversion or type conversion warning. Yep. So moving on, for the second query, what we are doing is like we are not including that n. We are removing that n, and let's execute the query. And now if I look at the table one index seek operator, we are doing an index seek, not an index scan. And if you look at it here, we are estimating 4.9 rows, and then we are returning 10 rows. And again, we are not reading 15 lakhs 99,000 record. Instead, we are reading only the required records. That is, we are reading just 10 rows and then returning that 10 rows. So that means we are able to use this seek to avoid excessive reads, and we are just pointing to the exact records. We are reading that, and then we are displaying the results. And here we don't have any kind of warnings. So that's it for this video. Thanks for watching. Have a great day. Jai Hind.